Hi everyone, we've got here a super tricky SUVAT question. So I thought it'd be good to have a look at this one because it's worth 9 marks and it illustrates some really quite advanced thinking on SUVATs. So it says two cars A and B are moving in the same direction along a straight horizontal road. Car A is moving with a uniform acceleration of 0.4 meters per second squared and car B is moving with a uniform acceleration of 0.5 meters per second squared. At the instant when B is 200 meters behind A, the speed of A is 35 meters per second and the speed of B is 44 meters per second. Find the speed of B when it overtakes A. Such a complicated idea and it's worth 9 marks. So let's have a little illustration to see what's happening with these two cars. Okay, so here is car A and here is car B. Okay, now car A is 200 meters behind car A. Okay, so it says at the instant when B is 200 meters behind A, the speed of A is 35. So we're going to say the initial speed is 35 meters per second for A. And the speed of B is 44. So we're going to say that the initial speed for B is 44 meters per second. Okay. Now basically we've got to try and find the speed of B when it overtakes A. So over here, further down the road, we've got the point where they're both level with each other. Okay, so we've got car A and we've got car B. Now let's say that car A has travelled a distance of X. Okay, so it's travelled a distance of X. So from there to there in that same period of time. Okay, so that means that this distance here is also X there. Now let's write down SUVATs and think about the two separate cars. So first of all, we're going to write down a SUVAT for car A. So SUVAT. The distance that A has travelled when at the point when A and B are parallel and B overtakes A is X. A's initial speed was 35 meters per second. We're not worried about how fast A is going when B overtakes it. We know that the acceleration of A is 0.4 meters per second squared and it overtakes it at time t. So that's the information that we've got for A. So we can write a SUVAT for A. So it's going to be S is equal to UT add a half AT squared. Okay, so X is equal to 35t plus a half times by 0.4 times by t squared. Okay, so that's our SUVAT for A. Now let's think about B. Let's write down SUVAT, S-U-V-A-T. Now the thing that's, and I think this is the trickiest bit of this whole question, from the starting point, okay, where we started, basically what's happened is B, it's moved that same distance X, the same as A has, but in order to have been parallel with A, it has to have also covered that additional 200 meters that it was behind. So at the moment when car B overtakes car A, the distance that it's travelled is X plus 200. Because it's gone the same distance that A has gone, but it had an additional 200 meters that it had to catch up as well. And that, I think, is the trickiest bit of this whole question. Okay, its initial speed for B was 44 meters per second. Again, we're not worried about how fast B was going when it overtook A. The acceleration for B was 0.5 meters per second. And the time at which it overtook was t, because they both overtake at the same value of time. So we can now write down a SUVAT equation for B. So S is equal to UT add a half AT squared again. Okay, so we've now got X plus 200 is equal to U, which is 44, times by T plus a half times A, which is 0.5, times by T squared. Now, we've basically got essentially now a pair of simultaneous equations that we need to solve. Now, if we rearrange these two equations, we can actually make them both, if we make them both equal to X, we can solve them, put them equal to each other and solve for T. So let's take off 200 from this equation here. Okay, so we're going to take off 200 from this equation here, and let's see what that's going to give us. So that gives us 44t plus a half times by 0.5 t squared minus 200 is equal to x. Okay, and then so that's going to say, you know, is equal to x. This other equation is already equal to x, so it's 35t add a half times by 0.4 t squared. So there we go. We've basically put the two equations both equal to x and put them equal to each other. So we can now go about solving this pair of simultaneous equations. Okay, so let's add, it doesn't really matter how we do it. Let's think about what we're going to do. So let's take off, let's get the t's onto one side. So if we do a half times 0.4, a half 0.5, so we're going to take that over to that side. That's going to give me a half times by 0.1 t squared. Okay, that's fine. And then let's take that onto that side as well. So we're going to do 44 minus 35 is going to be 9t. There we go. So that's plus. And then we've got here our minus 200. And that is now equal to 0. Okay, so let's see what that's going to give us. So that's going to give us an equation which is 0.05 t squared plus 9t minus 200 equals 0. And that's our quadratic. Okay, so that's good. So now we can just literally see if we can factorize that. We could times everything by 20. Well, we can put that into our calculator, get the solutions, and reverse engineer the brackets. Okay, so if we pop that into our calculator and solve it, we find out that the brackets for this one are t minus 20 and t plus 200. Okay, which gives us values of t is equal to 20 and the value of t is equal to minus 200. Okay, so yeah, we really don't want that one because it's negative value of time. So it's 20 seconds is the time at which B overtakes A. So now we've just got to find out what the speed of B is when it overtakes. So we go back to our SUVAT now. Let's write down the SUVAT now, SUVAT. So we know that our distance, now let's think about what we're going to do here. We don't need to worry about that this time. We know that our initial speed of B was 44. We're not worried about how, we are trying to find out how fast it's going. That's what we want to find, V. We know the acceleration is 0.5, and we now know that the time is 20 seconds. So this is a SUVAT for B now. So let's think about that. So we're now going to say the appropriate SUVAT here will be V is equal to U plus AT. So we're going to say V is equal to U, which is 44, plus the acceleration, which is 0.5, times the time, which is 20. Let's see what that is. So 44 plus 0.5 times by 20, and that gives us V is equal to 54 meters per second, which is the correct final answer. Now, I hope you found that helpful, because I know that I think was quite conceptually difficult, especially this idea of the relative motion of the two of them and thinking about how far they've both gone at the point where B overtook A. I think, you know, when I first attempted this question, I made the mistake of putting x minus 200 there, because I sort of like was thinking, oh, you know, I just kind of like hadn't visualized it correctly. So I hope you found that useful, but that is, I would say, really, you know, like a grade A kind of AS SUVAT question. I hope you found that helpful, and I will see you in the next video.